tutorial, we will be discussing a review of solubility and then relating it to KSP. So just a review of some different types of reactions. We have an acid-base reaction here where the H and the OH come together to form water. A gas forming, for instance here with CO2. And then a precipitation reaction where lead 2 iodide is formed. We also have oxidation reductions, which is the transfer of electrons. So here, the iron is losing electrons and the oxygen is gaining electrons to form this compound. An unsaturated solution has more solute that can be dissolved in a given volume of solvent, whereas a saturated solution is the maximum amount of solute that has been dissolved in a given volume of solvent, and a supersaturated solution is the solution that exceeded the amount of solute dissolved that is allowed by a given amount of solvent. Therefore, you're going to see a precipitate, or a solid being formed at the bottom, and in order to have this happen, you would have had to have temperature or pressure change to dissolve more solute than you should have been able to. Solubility is the amount of the solute that can be completely dissolved in a given volume of solvent or water at a specified temperature. It will not always be water, but most of the time it will. Molar solubility is the number of moles, the amount of a solute that will be dissolved in 1 liter. So just like molarity is moles per liter for concentration, molar solubility is referring to moles in liters. It's the molarity of the saturated salt solution. All ionic compounds dissolve in water to some degree. However, many compounds have such a low solubility in water, we classify them as insoluble. The concept of equilibrium can be used to determine the salt ions' relative solubilities in water. The equilibrium constant for the dissociation of a solid salt into the aqueous ions is called the solubility product. So here we have the equilibrium, K. You've seen that several times before. Now we have SP at the end for solubility product. So it's just simply said KSP. For an ionic solid, let's say an example of Mn x to the n, the dissociation reaction is, well, we have N of the M, so the N comes in front. Remember, in order to get these N and M at the bottom to begin with, we crisscrossed it. So we uncross it to get that charge. So that M plus is because of the number of anions we have. M, for the next one, is how many anions we have. X is the anion, and N minus is that charge. The solubility product then would be, because the S, because it originally started as a solid, that's not included. We only have the right hand side of the reaction. We have the cation and the anion. Notice that the coefficients are now raised. They're now getting to the power of it. So here's a couple examples. We have PbCl2. We have 2 chlorines and 1 lead ion. The equilibrium constant would be then that lead ion times the chlorine anion squared. Remember that 2 came from the coefficient. KSP numerical value is the product of the maximum ion concentrations and molarity for a saturated solution to occur. Numerical values greater than the KSP value indicate the formation of a solid or precipitate that falls to the bottom or is suspended in solution. Generally, the larger the negative value times 10 to the negative x, the larger the more negative that is. So times 10 to the negative 1 versus times 10 to the negative 30, for instance. The more insoluble the salt's going to be because less is going to dissolve. That KSP is going to be smaller and smaller and smaller. The molar solubility, represented by the letter S, is related to the KSP. Cannot always compare solubilities of compounds by comparing their KSPs. In order to compare KSPs, the compound must have the same dissociation stoichiometry. For instance, copper iodide versus lead chloride. That breaks up into Cu2 plus and 2I minus. Lead chloride breaks down to Pb 2 plus and 2 chlorine minus. Because they break up the same, you can compare them. If we look at these two, we have 3 nickel 2 plus and 2 phosphates 3 minus versus 1 Ag plus and 1 Br minus. Because they don't break up into the same quantity of ions, you cannot compare them. So let's do a little bit of an example. You have silver chloride. It breaks down into silver and chlorine. If the saturated solution, so in other words the maximum amount it can hold, has a concentration of 1.67 times 10 to the negative 5, you can determine the solubility equilibrium, the KSP, by multiplying those concentrations together. So 1.67 times 10 to the negative 5 times 1.67 times 10 to the negative 5. That gives us the equilibrium constant of 2.79 times 10 to the negative 10. So what does this value represent? The solution is saturated under these conditions. So as long as you have this amount of molarity, then that is going to dissolve. Anything above that, it is not going to dissolve. It's going to fall out of solution. And that is KSP and a review of solubility.